Hey guys, it's Matt, your advanced chemistry teacher, and every year since I've been teaching chemistry, which is now about 15 years or so, I've always started off the year with a demo. Now, given that you're starting the year remotely, I couldn't give you an in-person demo, so I thought I'd give you a video demo. And really the point of this demo is, first of all, it's really cool, and you guys know I love demos, I love reactions. It's one of the reasons that I think it's a great job to be a chemistry teacher. But secondly, there is so much awesome chemistry happening in this demo. Some of it we covered last year, some of it we didn't. Even if we did cover it last year, there's probably a good chance that you didn't remember a lot of it. So this is really just a way for us to start a conversation, a chemistry conversation around a chemical demonstration. So hopefully it works. Here we go. All right, I gotta talk loud because I'm talking over the fume hood. So the goal of this really is, again, well, demos are fun. Let's do a demo. But secondly, think about things that you feel you understand, things you know maybe from last year, your past experiences, things you feel you kind of know, have some sense of what's happening, and then things you feel like you really don't understand, don't know, but are questions you have that we're gonna answer this year in advanced chemistry. Okay, so here is what I have set up. I have a concentrated hydrochloric acid. What I mean by concentrated is I'm going to show you this bottle here, and look at that molarity, 12 moles per liter. That's as concentrated as you can buy it. I'm going to open up the cap here, and then you can see, you can't really see it too well, but it's actually a fuming acid, which is why I have the fume knit on, because it'll instantly go into the vapor phase right by opening the cap, so you don't even want to really have that in the space outside the fume. So the other acid I have is in this flask, and this is concentrated nitric acid, and you can see the molarity on that, 15.8, a little bit higher molarity because you can dissolve a little bit more of nitric acid in water. We'll talk about why that is later. And lastly, we have elemental copper. First, I'm going to drop the elemental copper into the concentrated hydrochloric acid. Here we go. Oh, it's you might say I threw away my shot. Oh, I just messed up that joke because this is also called copper shot. One of the interesting things about chemistry is time is everything. So if we let this react long enough, this has been reacting for a couple of days. You see, it looks like that. All right, let's do the same thing now with our other concentrated acid, our nitric acid. So here we go. Put the copper in, and I'm going to stopper this. And you can see immediately we have a reaction. To zoom in the best that I can so you can see that, maybe the size a little bit easier. You're already seeing some really beautiful colors, and people who I taught chemistry last year, you might remember that's one of the things that I love about chemistry, is just the absolute beauty of it, the fantastic colors. And we get so caught up in math and equations and sort of problem solving that sometimes I think you gotta take a little bit of time, smell the roses, and appreciate the beauty of the chemical reaction. Alright, so I'm going to let that go. This video is probably going to have to be paused because this demo takes a little while. But I'm going to zoom out so you can see the full setup. Okay, so I have this flask with a stopper in it, and if I follow that stopper, it's going into this other Erlenmeyer flask, and it's got a tube. The tube is pretty weathered at this point because I've done this demo a couple times. It hasn't been working on it, well, to be honest. But there it is. The tube is going into water. So let's go back to the flask of interest, and you can start to see another reason that I'm doing this in the fume hood. You might also remember last year from chemistry, if you can ever see a gas, that's a bad sign. I think every gas that is visible is also poisonous. So we want to make sure to do this in the fume hood, but really for my safety. You don't have to worry about it because you're not here. But I really don't want to breathe in the NO2, the nitrous dioxide gas, any more than you would if you're actually here with me, which I wish you were. Okay, so I'm going to let this go a little bit. A couple things are happening, and again, you're thinking about what do I feel like I definitely know, what do I feel like I maybe know, and what do I feel like I definitely don't know. So you can see here, I think you can see this. You can see, you can zoom out here, see some bubbles forming over there, right? So going back to here, you could probably figure out where those bubbles are coming from. That's something you should hopefully feel pretty confident in. And I'm just going to let this go so you can see what's happening in these fluids. Okay. So this has been going on for a while, and it looks like the bubbling has stopped. If you take a look at this water, And you can see that it's going up the tube, almost like it's being sucked up by a straw. Alright, I think so. This is finally happening though.